Many of you have the idea what is the mineral. Okay, you have seen it. The minerals, as we say, they are naturally occurring homogeneous substances. Okay, having definite atomic structure, definite chemical composition. Okay, and they have a set of physical properties. Okay, so they are the inorganic substance. Definite atomic structure in the sense we are talking is that they have, each and every mineral have a constant atomic structure. This atomic structure is result from their atomic bonding. Okay, bonding of the atoms of the elements which form the minerals, and they are also have more or less definite chemical composition. Here the definite means we can define the chemical composition of a mineral by a chemical formula. Suppose you take the example of quartz. All of you heard that name quartz. Quartz, we can define its chemical composition by a chemical formula SiO2. Okay, SiO2. So this definite for this atomic structure is this is constant atomic structure, and definite chemical composition means we can define the chemical composition of the mineral, okay, by a chemical formula. So each and every mineral has a constant physical properties, okay, which are used in the identification of the mineral. So this mineral we can identify, we can separate one mineral from the other based on their physical properties. Okay, mainly in the field or in the laboratory, we can identify the mineral based on their certain constant physical properties, a set of constant physical properties. This physical property is due to the composition of the mineral. Okay, their elements, their bonding, all this. So the mineral can be divided into two groups. One is the rock forming mineral. Okay, as you know, the crust is composed of the mainly the rock, and when this rock eroded and forming the soil. So top layer of the earth crust in many parts is soil, which are the daughter products of the rocks. Now these rocks are composed of mineral. Okay, so we will having rock forming mineral. So these are very important for us, for as a civil engineer. This mineral which constitute the rocks give the physical strength of the rocks. Then we have ore forming mineral. Okay, so bauxite, it is the aluminum ore, no? You know bauxite. Then say pyrite, FeS, it is the ore of the iron. So we have two categories. So quartz, feldspar, they form the rocks. We call them rock forming mineral. And there are certain ore forming mineral, so which are having economic importance. Okay. So these are the building blocks of the rocks. Okay, these are the building blocks of the rocks, and that means these rocks are composed of mineral. Okay, and these minerals help us to know about the process of formation and history of the rocks. So by studying the mineral, their grain size, their shape, their size, okay, this help us to know that whether the rock has been formed at the surface of the earth, whether the rock has been formed below the surface of the earth, whether the rock has been formed from the magma, or whether the rock has been formed from the lava. Okay, so this will tell us the formation and history of the rocks. Okay, formation and history of the rocks, and it also determines the physical and chemical characteristics. So a rock, whether it will having a high strength or say having more compressive strength, more tensile strength, whether or less tensile strength, or more abrasive strengths. Okay, so these all depends on the composition of the mineral. Okay, the physical and chemical. So it is very important. You are having a type of area, you are going to construct the certain structure. Okay, now you will test the strength of the rock. Okay, just you are going in the field, or you will test the different laboratory tests or different in situ tests for determine the modulus of rigidity, compressive strength or other strength, shear strength. So all these strengths of the rocks mainly depends on the what mineral it is formed. This is one very important point, and other will be the whether the rock has been subjected to any deformation. Okay, so anyway, minerals determines the physical and chemical strength of the. So you know some of the rocks or mineral dissolve in water, some are not. Okay, if you have limestone, calcium carbonate, okay, this will be soluble in water, so it will having the effect of the rain. But in case of say granite, it is composed of other minerals, say quartz, it will not soluble in water. So these are the chemical characteristics. It depends upon the composition of the mineral. So each minerals is characterized by a specific composition. Okay, as we discussed, a specific crystal structure. So this mineral, they are nothing but some crystals. What is the crystal? These crystals are formed because of the atomic bonding of certain elements. So minerals are formed by the elements, and because of their bonding, they show a different crystal structure. And each of the mineral is having a specific stability range. So a particular mineral may be withstand a particular pressure temperature range, but other mineral cannot be withstand that pressure temperature range. That means a mineral may be resistant to high pressure or high temperature, but other mineral may not be resistant to high pressure and high temperature. So each of the minerals are this. See, all this why we are studying, this will give a certain idea regarding the study of the rock in later stage. Okay. So we are having lots of minerals. Okay, minerals groups. Okay. So this is we are having thousands of minerals in the earth. Okay, millions of minerals, and these are separated into different groups. These groups are made based on their crystal structure, okay, and based on their chemistry. So different minerals are grouped in a particular group, okay, assembled in a particular group based on their crystal structure and based on their chemistry. Okay. So we have different mineral group: oxide, silicates, carbonates, sulfides, sulfates, chlorides. So you know oxide, we have quartz. You see the formula SiO2. Okay, magnetite Fe3O4, like that. These are the oxide. These are important mineral of the rock. Then we have silicates. Silicates are the most important rock forming mineral. Okay, so we have Si3O8, you know, Si2O10. This is silicates. Okay, feldspar, mica, hornblende. These are also important rock forming mineral which are composed of some silicates. Okay, silicates means they are the combination of, we have a tetrahedron or other bonding of Si elements and oxygen. Okay, then we have the carbonates, calcite. Okay, then we have sulfide, pyrite. These are all ore forming mineral, na? Pyrites, galena, sphalerite. Okay, these are the zinc sulfate, means this is the ore of zinc. This is the ore of lead. Okay, so these are sulfate. Then we have sulfate, gypsum. Okay, calcium sulfate, it is gypsum. And we have chloride, rock salt, NaCl. Okay, the normal salt. These. So these are some of the minerals which are in our laboratory, but this time you may not be able to check those minerals. We have in our laboratory very beautiful mineral hand specimen of the minerals. Okay, so over 4,000 minerals exist in it. This is a rough estimation. It is not like that only the 4,000. It may be increase or decrease. Okay, so you know all the minerals are composed of mainly 8 elements. Remember, only 8 elements form the bulk of the mineral composition. This form the bulk of the. There are certain other elements, but their presence is very less. But this form the bulk of the composition of the mineral on the earth. What are these? Oxygen, silicon, aluminum, iron, calcium, potassium, sodium, and magnesium. These are the 8 elements. If you check here, you will get these 8 elements mainly. Okay. Now, these minerals are composed of 8 these elements, and this mineral constituting the rocks. Okay, constituting the rocks. So otherwise, the rocks which are formed in the crust, okay, on the earth. So mainly the bulk composition of the crust is composed of mainly these 8 elements. Okay, it is not like the other elements are there. The uranium is there, very less amount. Okay, very less. So mainly these elements, 8 elements, form the bulk of the earth crust chemistry. Okay, now how the minerals are formed? Okay, so minerals may be form a solution. Suppose you have a solution where some of the elements are highly saturated. So what happened? These highly saturated elements will be precipitated, forming crystal of the rock. Sorry, crystal of the mineral. Okay, this is one. Then magma, below the surface of the earth, after astronosphere, we have the mantle. Mantle are composed of hot molten metal. These are nothing but some molten metal means magma. Okay, so this magma during cooling they form certain crystal. This magma are composed of 8 elements. As I told you, this magma is composed of 8 elements. So mainly composed, and when they cools down, they form the crystal. They form the crystal of the mineral. So from the magma we may have minerals. Okay, now this will help us whether the magma cools very slowly, then size of the crystal will be bigger. Size of the, I will discuss this points in our rock. Okay, igneous rock. Now, and when it cools very fast, then the crystal size will be smaller. Then when grain size of the mineral will be smaller. Okay, so the mineral which are formed due to the slow cooling of magma below the surface of the earth, where the magma are there, the temperature of the magma and neighboring temperature of the environment more or less same. So they cools very slowly. When the magma cools very slowly, that elements will have enough time to crystallize along a center. Okay, nucleus center. So it will form bigger mineral. And so it is like that. Here. Okay. Okay. So are we seeing this? Dekisha?
Yes, sir.
Yes, sir.
Okay. Okay, suppose this is a body of a magma, and magma, these are hot molten material, so they are composed of elements, no? Mainly the 8 elements, bulk, other elements will be there. Now when it starts cooling, what happens? It will form nucleus. It will form nucleus of the particular element. Suppose this is the nucleus of silicon, this is say iron, like that. This is say calcium. Now what happened? Now we have a lot of things. Sorry. Like the all these elements which will be dispersed, okay, they will be distributed throughout the magma. Now what happened when the magma starts cooling? Okay, when the magma starts cooling, suppose you have a center here nucleus, then the this having the problem, okay,
Sir,
then it will having that's all elements. I don't know why it is making this shape. Why they can making this shape? Anyway, so this is the nucleus of a silicon. Now all the silicon element will be coming to here. Okay, it will concentrate here. Now as it cools slowly, this will become bigger and bigger. So later on, what happen? You will have a bigger crystal here. Similarly, you will have a bigger crystal here. You will have a bigger crystal here. You will have a bigger, because all the elements of the same type, they will be dispersed to the particular nucleus. You will have lots of nucleus, millions of nucleus, and because it cools very slowly, it will have enough time to disperse along a particular nucleus, so it will become bigger and bigger in size. This is magma. Now suppose this magma coming to the surface of the earth, okay, so this magma coming to the surface of the earth and it cools very fast, so this nucleus which will be formed, okay, this and the elements here, they will not have enough time, to concentrate to come to this location, okay, and they will concentrate near neighboring area. So here what happened, a longer distance, the elements from here to come here, elements from, okay, come here, from longer distance it can come to a particular nucleus because it cools very slowly and it has enough time to disperse for a longer distance to concentrate along a nucleus. But when it cools very fast, what happened, the nucleus will concentrate, in the nucleus you will have the elements of neighboring area. So that means it will having lots number of minerals, because it cannot travel longer distance, it will be crystallized along the local area, as you say, in a neighboring area. So here what you have lots many minerals, of smaller grains. বুঝি পাইছানে? You have lots many minerals of small, because the distance travel from to concentrate along the nucleus, the distance will be smaller. The longer, because already it cannot travel longer distance, because it cools very fast, become harder, it become crystal. But here the cools very slowly and it become a molten material for longer time, so the elements from a longer distance can travel to concentrate along a nucleus. So here you will have smaller number of bigger crystal, here you have larger number of smaller crystal. Is it clear? বুঝি পাইছা? Is it not clear? Then I'll
এইটো process
Yes.
আৰু এবাৰ কৈ দিব নি sir?
আৰু এবাৰ কৈ দিম। Very good, thank you.
Sir, smaller crystal to.
Suppose
Sir, small crystal formation to.
for small crystal মই কৈ আছো, suppose again I repeat, suppose this is a magma which is below the surface of the earth and it is in a molten state, and this magma, what is this magma? They are composed of certain element. Let us take those 8 elements, okay, which form the bulk of the magma. Now this magma cools slowly, because the magma where it was there and the neighboring environment, these are the neighboring environment, this is the body of the magma, so let us take, and these are the neighboring, there the temperature of the magma and neighboring temperature is more or less same, but due to certain condition the magma start cools. When it start cools, what it means? It will crystallize. That means liquid form solid. That is we call crystal. Okay. Now, as it cools slowly, and when the crystallization takes place, when the solid form from a liquid, what will happen? The different element forming the nucleus at different location. Okay, different location, different elements will form in the different, and the elements of the same nature, they will be dispersed to a particular nucleus. Suppose this is the nucleus of silicon, so neighboring silicon will be dispersed to this nucleus and forming the solid. Okay, suppose this is calcium, so all the calcium will be coming here. So this is iron, all the iron will be coming here, and it is crystallized along this nucleus. So you may have different number of nucleus throughout the magma. Okay, it is not that only single nucleus will be there, lots of nucleus will be forming, and here as it cools slowly, the elements of the same nature can disperse, move for a longer distance to concentrate along the nucleus. So as large number of elements will come from a longer distance, because it cools slowly, it become molten. In the molten state it can travel, so longer distance, so it will form a bigger and bigger crystal. So here also forming a bigger and bigger crystal. So what will happen here? You will have small number of bigger crystal, small number of bigger crystal. So crystal size will be bigger. Okay, crystal size will be bigger. Now this magma comes to the surface of the earth because of the volcanic eruption. We call them lava. And what happened? The temperature of the lava and the surface temperature, there is a large gap. Okay, our earth temperature is 40 degrees centigrade. The temperature of the lava may be 8,800 to 1600 degrees centigrade. So there is a gap, large gap, drastic sense. So this lava cools very fast. When it cools very fast, it becomes solid. Cools very fast means crystal form. So here the elements will not have enough time to move longer distance. It will not have enough time to move longer distance. So they will form a crystal from the neighboring area. So suppose this is the nucleus of silica. Okay, so the neighboring silica will come here. Then what will happen? Another silica will form here. So because it cannot travel to this longer distance, because already become crystallized. So they will crystallize in a small amount in the local area. That means you have large number of nucleus, solid, and their size will be finer because the elements cannot travel longer distance. Element cannot travel longer distance to concentrate here. Got it? So what happened? So you take an idea, the mineral which are crystallized below the surface of the earth, they will be of bigger grain size, and the mineral which will be crystallized at the surface of the earth, they will be of small grain. Okay, so you will have small number of crystal here, you will have large number of crystal grains here. Is it clear? Bujhe bisa?
Yes, sir.
I see, sir.
This will again will come to the our rock chapter when we will discuss the rock. Okay, so this is one. Okay, just a minute, huh? Net is very slow. Okay. Now this is now is it clear? No, respond koriba de. Itu buji paisa na? So cool slowly beneath the earth surface. So you will have a bigger grains. Example, the rock is granite. And extrusive means which is formed at the surface of the earth. Cools repeatedly, as I told you just now, and you will have large number of fine grain. Example, basalt. Then there will be another type of process which form the minerals. This is in the solid stage. Suppose you have a hard rock on the surface of the earth. Okay. Now, because of the change of temperature and pressure, these rocks may be forming a different kind of rock. We call them metamorphism. So, this solid becomes solid. So, you will have different type of mineral from the original mineral. Suppose you have a granite rock. This is granite rock. You have a different kind of mineral. Now, it is subjected to a change environment of temperature and pressure. Suppose it is subjected to high temperature and pressure. The mineral of this granite will be forming a different kind of texture and structure and different type of mineral. Okay. So this is one kind of things which is formed in the solid stage. So what we know, the minerals may be from a solution. Okay. Maybe from magma, maybe from a solid transformation from a solid rock. So physical properties. So as I discuss in the definition, the physical properties of the minerals. Okay, physical properties of the minerals are having a constant set of each mineral having a constant set of physical properties. Okay, these physical properties can be determined in the sample. Okay, so suppose you taking the sample in the laboratory. Okay, in the hand specimen, you can check the different type of mineral, hardness, different color, different streak, different properties are there. We will discuss one by one. So what are the different physical properties of the mineral? Color is one important. Then one term is called streak. We'll discuss. Then luster, then hardness, habit, cleavage, fracture, then odor, tenacity, specific gravity, and crystal form or habit we call it. So these are some of the properties, physical properties of the mineral. We can check in the laboratory or in the field by taking a mineral specimen, and this will help us to identify the mineral. We can classify the mineral or we can name the mineral. Okay. And very importantly, the correct identification. This is a physical test. Okay, you can suppose you are going to the field, you are in the field, you want to identify a particular rock and their constituent mineral. Then what you will do? You will go for physical test. Okay, this is somehow you can identify the mineral as well as the rock. But proper identification can be done with the polarizing microscope. Okay, in the microscope, if we check the mineral by making some slides, okay, this will confirm our test. And more confirmation test is can be provided in XRD, X-ray diffractometer. In the X-ray diffractometer, you can for any kind of sample, whether you take the soil sample, rock sample, mineral sample, it can analyze element wise, which elements contain how much percentage. Okay, suppose for a better understanding of a soil, you take some soil sample, okay, you put it in the XRD machine, then it will analyze the soil into different element wise, what elements, whether how much silicon is there, how much carbon is there, how much this means irons are there, okay, oxygen are there. So everything it will analyze element wise. Then once you know the percentage of element, you can classify the sample. Maybe this soil, maybe mineral, maybe other. Whether in case of soil, whether it is sand, whether it is clay, whether it is gravel, you can analyze and which is composed of what elements. This is X-ray, XRD, we call it X-ray diffractometer. Okay, so mineral. Now one by one, if we discuss the physical property, the color, color is very one of the important physical properties of the mineral. All of you know, color of a rose is red. What it means? It means that the flower which is red, it reflect the red wavelength of the white light, and it absorb all the wavelength. Okay, so if we discuss color, then we can see the things like that. You know, these three, blue, green, red, they are called the primary additive color. Okay, they are called the primary additive, and these are the wavelength of the white light. You all, তোমালোকে ইলেক্ট্রোমেগনেটিক স্পেক্ট্ৰামৰ অলপ আইডিয়া আছে ন? অলপ পঢ়িছা নহয়? মই নুসুধোৱে, আই এম নট আস্কিং এনি
Yes,
কুৱেশ্যন।
sir.
এনে অলপতো আইডিয়া আছে চাগে, ফিজিক্সত পঢ়িছা? Electromagnetic spectrum, blue wavelength.
Hi, sir.
Yes, sir. Yes,
Okay,
sir.
okay. So you know blue, green, and red wavelength. Now, if you say the color, then what? Blue, green, and red are called primary additive color. Primary additive color. That means when we add blue plus green plus red in equal proportion, we will get the white light. We will get the white. So white wavelength is composed of this blue, green, and red. If we add blue, green, and red, then we will get white. Okay. Now, then this yellow, magenta, and cyan, they are called primary subtractive color. They are additive color, they are subtractive color. Why? When we subtract blue from white, okay, blue from white, then we got yellow. When we subtract green from white, we get magenta. When we subtract red from white, we get cyan. Okay, so okay, then now it will be clear. Suppose this is the angle blue, green, and red. They are called primary additive color. Okay. So if we add them equally, we will get white here. Okay. We will get now yellow is the color equal subtracted color. When you subtract blue from white light, you will get yellow. When you subtract green from white, you will get magenta. And when you subtract red from white, you will get cyan color. Okay, they are called cyan. Now, if we add cyan plus yellow plus magenta, we will get black color. So in other side of the triangle, you will have say. Now we see that all the gamut of color you can get from this 6 color. That is why these 6 color are called primary color. Okay, mainly these 3 colors are the mainly primary. You can use this color to get this color. Anyway, these 3 are called primary additive color. These 3 are called primary subtractive color. And using this color, you can get the different gamut of color. Now you see, if you add red and green in equal proportion, you will get yellow. This is very interesting. Now if you add green and blue, you will get cyan, and if you add red and blue, you will get magenta. Now we are having a digital camera. Earlier the analog cameras are there. You have to use the reel, then you have to develop in the photo studio. So how they will get the color? This is the process. Okay. Now why I can discuss this then why some of the leaves become at the old stage become yellow, and now generally the leaves are green, and why some of the leaves are become yellow at the old stage, and why at the budding stage they are reddish in color, cyan in color. Now these are the things. Now this triangle will give you all the type of color. Now suppose you want to have a magenta, you add red and blue. You have blue and green, you want to have a cyan, you add blue and green. So these are called the primary additive and primary color. So in case of mineral also, the color is from like that. Color is from like that. So that is why I discussed this point. Is it clear? Buji Pisha?
Yes, sir.
Okay. Now I'll go to this. So due to reflection, reflection of certain wavelength of the light. So which will reflect this? The atom making the crystal. This crystal from the mineral. So some of the minerals are green. Why this mineral greens? The atom of the crystal of this mineral, they absorb all the wavelength and it reflect the green wavelength. Okay. So if we call a different type of process or types, we call idiochromatic. So a constant color, okay, it is not changing any color, it is copper. Okay, allochromatic, variable of colors. Okay, quartz you will have, when you discuss the quartz, you will see quartz can show different type of color. Okay, we call allochromatic. Then pseudochromatic, a false color sometimes you will get, not the actual color. Now if you check the mineral in microscope, it shows the change of color, very beautiful color. If you can check it, a particular mineral in a microscope, we call it pleochlorism. That means pleochlorism is that you can, if rotate the microscope and the slide, it will show different type of color. It will play with the color. Okay, change in color. Okay, a diamond, it will say different type of color. Okay, so then change of color, rate of change of color on rotation and intensity is low. The Labrador, a different type of things, a different type of changing color. And these are rainbow colors in interior or exterior surface. So limonite, hemanite, they will see the whole gamut of color like the rainbows. Okay, iridescence. So these are some of the term in color. I don't think you should remember all this name, but you just have the idea. Okay, so tarnish. So this is a change of original color due to oxidation. Okay, so when the minerals are there, it is oxidized, it will change its original color. So these are time of the period. But what is color? Color of a mineral is because of the reflection of certain wavelength because by the atom which from the crystal of the mineral. Okay, we will have different color of the mineral. Okay, these are some of the term related to the what we call microscopic sense, microscope, when you study the mineral. Okay. Streak is the color of the powder of the mineral. Okay, so it is important for certain mineral to identify the mineral. Some of the mineral may have same color, but their streak is different. What is streak? Example, I am writing in a board with a chalk. What is the color of the chalk? Is white. Okay, now I write on the board. Okay, when I write a certain word in the board, that word which reflect in the white color, this is the color of the powder of the chalk. Thus not the color of the chalk. You got it? This is also white, no problem. So because chalk is white, the color is white. So this is called streak. What is this? Color reflected by the mineral. Okay, now streak, you take the mineral, you rub it in a porcelain plate. What is the color you see in the porcelain plate? This is the streak. Best example is chalk. When I write in the yellow board or black board, okay, the chalk is color maybe green, maybe red, maybe white. Generally we use the white chalks. Some color chalk also there. I take the chalk, okay, I see the color of the chalk is white. Now I write in the board, the what you see in the board is the streak. That is the color of the powder of the chalk. Okay, this is called streak. Now it is the color of the powder of the mineral. How you can obtain? You obtain by rubbing. You just rub the mineral against a unglazed porcelain plate. There are certain plate. It is in our laboratory also. Okay, you rub it on the plate. Whatever the color it shows, that is the color of the powder of the mineral. In general, the color of the mineral and streak are more or less same, but there are certain variation in some of the mineral. These are very important. Suppose in normal, you take a mineral, say calcite, it is white in color. You rub it, you will get white color. This same, the color of the mineral and the streak is same, but there are certain variation. Say hematite, reddish black in color. But if you check in the unglazed porcelain plate, if you rub it, you will get cherry red color. Okay, cherry red color. So it is very important. Then chromite is black, it gives you light brown color. Just now, suppose two mineral, chromite is also black, and you have galena is also black. Okay, so both are black in color. So how you can differentiate? Now what you will do? You try to find out the streak. Okay, so you'll see the galena, it will give you the black color, but chromite will give you the light brown color in the streak. So this will help you to identify the mineral. Okay, so that we can do in our laboratory, but this time I don't think that you can do. These are some beautiful practical experience. Lots of minerals are there. You can cheat, you can check it in our laboratory, but this time you can say anything. Okay, so this is the streak, color of the powder of the mineral. Then what is lachar? Lachar is the general appearance. You take the mineral, you see in the white light, whatever the appearance it shows, it is called lachar of the mineral. It is so the reflectance of the mineral in the reflected light. Okay, different type of lachar are there. So suppose you take the mineral, you see it in the hand specimen, it shining like a metal. Okay, lachar is the shining, how it shine, what kind of shining it give in a normal light. Okay, now metallic luster is the hard brilliant luster. Okay, like a metal, magnetite and hematite are the example. Submetallic, if it is feebly displayed metallic luster, then chromite. Okay. Again, I am telling you that this you can check in the laboratory. Very interesting. Adamantine, brilliant laser like diamond, very hard. Okay. Then vitreous laser, this is exhibited by broken glass. Suppose you have a glass in your window. Okay, you take it, how it shine. This is called vitreous. Okay, how it shine. Quartz is one of the example. Then pearly laser, so it shine like a pearl. Okay, talc or calcite. Okay, then silky luster, it such shine like a silk fiber. No? Silk fiber is there. We use for stitching of the clothes. No, this silk fiber, how it shine like. So this is asbestos is an example. Resinous, it shows like the resins. Okay. Then greasy, it exhibit like the grease. Then dull or earthy, no luster, like the earthy material. Now you take the earth, it has no luster, no shining. So kaolin or bauxite is example. One example, bauxite mineral is in your laboratory. So bauxite luster is earthy luster. These are important for practical classes. Then pearly luster, you can have one example is mica. Okay, these are different type of luster.